Hi, my name is Casey Rehm. It's my pleasure today to interview Yasushi Yoshida. Yasushi is an architect here in Los Angeles. He is a faculty member at Cal Poly Pomona in Pomona, California, as well as Mount San Antonio College in Walnut, California. He has a long history of working professionally, integrating computational methods into the production of built works for offices like Morphosis, Gensler, Hitoshi Abe, and Michael Moulton. And additionally, we have collaborated on projects in the past and are continuing to do so in the future. So Yasushi,
Michael Moulton's office.
We met at Michael Moulton's office in 2005. So we've known each other for quite a while. And it's been pretty interesting for me to see how, we both kind of work with computational methods, but I think that there's a pretty big difference in terms of how we work, where I tend to use them more generatively. And you tend to utilize them more in an analytical way, or a way of like automating certain tasks within the kind of territory of resolving tectonics or architectural projects. Could you talk a little bit about kind of your approach to computational methods and architecture, and how that's maybe changed over the last 16 years that we've known each other?
Yeah.
or before. Yeah.
Sure. So first, I apologize for the camera angle, because like my laptop is over here, my main monitor is over here, so I'm looking at my main monitor. Anyways, so actually it goes back to probably around 2005, like right around when I met you. My motivation to learn computational tool was basically I tend to resort to a very repetitive manual things, especially when I was a student, like when I'm making physical models and things like that. Maybe it's a Japanese thing, but I don't mind repetitive tasks. So I become very diligent and make these models that's made out of a lot of parts, and I just keep doing things repetitively. Or even if it's in digital models, I would click like 16,000 times to make this facade, which at some point I kept thinking there should be a better way. And that's around 2004 when I first learned about generative components, and hence I started becoming interested in those parametric tools. And then I went to the generative components workshop, which is actually where I met Satoru. There was a local Los Angeles generative components workshop. So I always had this yearning to master these tools, but then I kept meeting these people who were way advanced than I was. Satoru was, who was interviewed a couple of weeks ago, was former computer programmer. So I sort of, I had this yearning and I kept trying to get good at it, but then also very quickly I knew there was, it takes me a lot of time to become a true expert. So my approach from there was to become somebody who's well versed in those computational tools, but also has a solid understanding in conventional architectural knowledge, whether it's the construction constraints or fabrication. Therefore, I was very much interested in CNC milling. When I was a student, I purchased a CNC milling machine for the first time, and that was sort of an intersection of physical and digital world. So that's where my interest started.
Yeah, I remember when we first met back in 2005, you used to make these kind of exquisite folded paper models, right? And that seems to be something that's continued into some of your more current experiments with kind of folded plate sheet metal systems. And you've always had this really clear relationship between like your construction of the 3D digital model, but also the kind of in relationship to how the parts are actually fabricated in kind of really direct way. Maybe you could maybe show some examples of that, or talk a little bit about the way you're thinking through like producing a digital model in relationship to those kind of tectonic processes.
Yes, sure. So I would say, let me share screen. So let me see. So very briefly, this is my visual resume. So I graduated from SCI-Arc around 2004 and practiced at a firm for about a decade. I would say maybe right around this time, when I was at SCI-Arc between 2001 and 2004, that's when SCI-Arc, or pretty much, architecture pedagogy in the US was really, I think it was early 90s when the digital tools were, starting to be explored. But around 2000, I think there was a real shift starting to happen where it was becoming more digital dominant. And SCI-Arc was making this shift from a very sort of handcraft workshop-based work ethics to a very sort of, taking advantage of digital tools. So we were the first generation probably at SCI-Arc where we got introduced to those digital tools first. And I was very sort of aware because of, I think, that climate, the demography of the students was, I would say, probably 50% very hand-making oriented people, students and faculty, and then 50% very digital-oriented people. So I was very sort of aware of this criticism about, yes, you can make all these amazing forms in computer, but like, how do you go about making them? That was often the criticism for classes that were taught using, animation software such as Maya, which is, a great tool to make these exquisite fluid forms. But no one really knew how to make them. So I always wanted to be able to learn that physical aspect of that too. So like I said, that's when, so these are kind of the tools that I started mastering, coming into architecture school without any design background. I think mastering the physical tools or manual drafting was harder than mastering the digital tools. So I jumped onto learning the digital tools first, became, I would say, pretty good at it. And then I got interested in more sort of intersection of digital and physical, which was the CNC milling, that kind of thing. Right out of the school, all of my skill set at the time in the professional architecture practice in Los Angeles almost had no value, probably with the exception of Frank Gehry's office, who were really taking advantage of those digital tools, but the other offices didn't have access to those softwares, were quite expensive at the time, so they didn't have access to those 3D tools, but more like AutoCAD. So if I didn't have any experience of drafting these detailed drawings in AutoCAD, I wasn't employable. So the only office who saw any value in my skill was Michael Molson's office, I think largely because he comes from Frank Gehry's office as well. So I got to work on this really complex housing project, which actually you worked on too, Casey, doing basically sort of a, smaller scale version of full-on digital coordination that this is sort of like the shrunk version of what Gehry's office was doing at the time, where you model everything structural, everything mechanical, everything facade related into this one model and find clash detection and coordination exercises. So this was exactly the kind of thing that I wanted to do as the new graduates and new employee at the office, because this was a way for me to provide my skills, as well as by doing that gain all these knowledge about anything related to construction and architectural detail. Oh, Casey, I think you're muted.
Sorry about that.
Yeah,
yeah, I think one thing that you kind of been looking at a lot is that relationship between like, building like the geometry and model relative to the physical reality. And I think this is a kind of interesting problem here, kind of going to another point where you have this, and beyond just this project, but kind of continuing, you've worked on a lot of projects where you have very complex geometry, right? That you are needing to communicate to people in the construction industry and fabricators, engineers. I think that there's this like interesting question then about, what is the actual valuable information in the 3D model? Like, how do you represent it for other trades? How do you represent it for your collaborators? In order to kind of communicate something which is moving from these kind of complex, super detailed 3D models that you produce to something that's going to be kind of built in the real world.
I mean, this is maybe not very, what's the right word? This is probably not a sexy sort of thing, but I think the most valuable aspect of these computational tools or 3D modeling when it comes to construction site or discussing with contractor, it's really the visual aspect. By that I don't mean visualization like rendering and photorealistic and spatial experience, but more like really sort of pointing out these very sort of concrete, specific, almost dumb, realistic problems, and there's some issue, and you visualize that issue, and you visualize how often that occurs, and how bad is the issue, that sort of thing. And once you have that image, you have all these other experts in the room, engineers or contractors. They immediately they get this intuitive understanding of the scope of the problem, and you can start discussing the solution. So this is probably a good example. The project at Morphosis office, which I got to work on with Satoru as well, Fair Tower in Paris, which didn't get built, but this was this sort of very sculptural form, 70-story building, where area calculation spreadsheet looks like this. This is probably less important, but this was like the very early generative components model of trying to calculate all of the column shadow area, which we had to subtract from one of the categories. But anyway, there was one, so this building had a double skin system. You have this regular curtain wall, actually slanted curtain wall, and then the maintenance catwalk, and then the metal mesh sunscreen facade where Satoru did all these amazing work. I was more on the analytical and detailing and execution side of that aspect. And one of the issues that came up during the meeting, coordination meeting, was that so this is a maintenance catwalk. And so the window washers, they have to walk around, and of course, it has this criteria of head clearance. And so it so happens that in the French building code, you have to be able to fit the 60 by 180 centimeter rectangle in any of the paths that you are supposed to walk through. And I think during the meeting, there were the local authorities, they were looking at the section drawing, and they found a lot of these conditions where you have a catwalk and glass facade and metal facade, right? And then if you try to put these rectangles, you get this head clearance issues. So, somebody says, oh, that's an issue, right? But you can't, this was probably like the late in the design development phase, so you can't change the form of the building because that's the project, right? So this became sort of a heated discussion, I think, probably for like a couple of weeks. Like, how bad is the problem? Like, how often does this happen? Like, if this happens all the time, then like the project is dead, right? But if this happens only every once in a while, then maybe we can try to work out a solution. One of the solutions that was suggested was maybe we can try to ease this criteria because no one's shaped rectangular. So maybe we can fit, if you can fit this sort of more, I mean, it looks like a coffin, but like if you can fit this blue shape instead of rectangle, you should be practically fine. But we can't do that if this happens 80% of the time. So I basically literally modeled using some automation, but not too much. Yeah, so basically we swept this whatever that shape is, the human shape, around the building on the entire catwalk. I think the total linear length, so it's probably 10 kilometers or something. But anyway, so we highlighted like where it happens and show the worst case scenario. And then I was actually able to quantify how much of the building is impacted. And we actually noticed that only that portion, which is actually the most dramatically curved area of the building form. So it wasn't actually very much. And then we could actually quantify it was only 270 meters out of 6.5 kilometer catwalk length. So that was only 4% of the entire length. So that's not that much of an issue. Then I think the local authorities were relieved, and they can work out some exception to the rules and et cetera, et cetera.
Yeah, that's like a kind of interesting place where you're communicating to maybe someone who's trained in architect isn't practicing a lot, but is primarily concerned like only about health, safety, and welfare. Like I know when you were working on the road, you were also kind of having to represent certain issues with the construction and fabrication of the project to a contractor. Like how does that differ in terms of the types of information that you're producing or trying to communicate to them?
I would say it's probably essentially the same thing, but like I talked about this first because I guess this is probably where I started learning these kind of tools and the way of working, and this was also where I got to learn digital project, which was the version of CATIA or variation of CATIA where digital Gary technologies developed. And so that's why I got to work on the Broad Museum at Gensler as part of the local architect team. Of course, the design architect was Gilles Renfro. I got to manage pretty much the entire 3D model on the architect side or local architect side. So the one on the left was the image from conceptual image from the competition phase, and this was the actual BIM model that got or digital project model that got developed. So obviously, as an executive architect, your mission is to sort of try to stick to the design intent as much as possible while facilitating to resolve all these technical issues that might work against you. So I'll skip some of these images. These are some different systems, but really when it comes down to communicating with the contractor, it really comes down to these 2D graphics that was produced off of the 3D model, especially because I was the only user in the office of this software, and also the general contractor didn't have the license for that software. So on the design team, and also, so I sort of became a liaison between the contractor and the design team in terms of anything that's related to building elements that's complexly shaped, which happens to be everywhere that's highlighted in pink on this drawing. So this was basically a printout of most of the sketches that I had to do during construction and administration phase. Basically, responding to what's called RFI's request for information. That's basically, I mean, I think this is weird. I'm explaining this to a Japanese audience in English, but it's basically, I think the whole construction system or convention is different in Japan. This is probably not necessary at all in Japan because it seems like Japanese contractors are way more flexible and willing to work with the architect. But in the US, you know, they have the contractual obligation to submit this paperwork to ask for clarification of design intent from all the design documents, right? So this is all the 2D sketches that I produced from digital model, you know, trying to address specific issues that was raised by contractors. It had to be in the form that everybody can understand and work off of.
Yeah, I mean, I think it's, you kind of raise an interesting point too, like a relationship between how the kind of building industry is different, maybe here in the States versus Japan. I've worked on some projects in Japan previously, and like a huge difference is like in Japan, the contractors, or when you work with a large contractor, they actually have like an in-house team of architects and engineers, right, that are working through a lot of the detailing, whereas in a US project, the architects are the ones that are kind of responsible for that. So it's kind of maybe as like a, not like a opposition to like the way you're thinking about this project and the communication, but just as like a kind of counterexample. I remember you were talking to me about the a project you were doing with Hitoshi Abe's office, where you made a kind of very highly accurate 3D geometrical model, but at the end of the day, the kind of information that the contractor needed and their in-house engineering and architecture team needed was actually like way less detailed than what you had produced. And so maybe you can talk a bit too about like in that case, like one in terms of like how do you kind of balance the kind of resolution that you're pushing the model to, but also like, you know, what the value is and still maintaining like an incredibly high level of tolerance in your own work if you're kind of always sending out kind of less highly resolved or highly tolerant data points to someone else.
Right. That's actually a loaded question that got me thinking about many different things, but I tried to answer one by one. But yeah, this was a very interesting experience. So this was work we did when I worked for Hitoshi Abe. He had an office in Los Angeles and he's based in Los Angeles, so he wanted to work from LA on this project in Japan in association with executive architecture firm. It was a joint venture between Hitoshi Abe's Atelier Hitoshi Abe and Kumeseke. But anyway, during the design phase, this building, it's you don't see very much here. It's probably the better images here. In plan, it looks deceivingly quite simple. The building footprint is basically, it basically consists of straight lines and arcs. So it has this slightly curved plan geometry, which seems very simple, but when you introduce the sloped roof, the geometry started becoming complex enough that if you underestimate the complexity, you know, it kind of throws you off. So to me, just because the way I've been working, you know, almost a decade before I started working for Hitoshi, to me, there was no question to just maintain a very rigorous 3D model just to be in control of the design, right? Like when you're going to draw, I mean, no matter what you're going to draw, whether you're drawing plan or whether you're drawing sections, I would always like to have this reference geometry in 3D. And it also applies not just to 3D, but like, so, yeah, like I'm sort of diverging from the original question, but yeah, so I think to stick to the original question, so there was no question that we maintain this 3D model to be exactly sure what we are drawing in 2D or anything. So this roof geometry actually turned out to be slightly complex. So most of the part, it consists of a flat surface or developable surface, which is basically that part is a part of a cone, right? So you can unroll a cone and turn it into a flat sheet. So everything that's shown in gray can be unrolled into a flat sheet. But the pink area, as you can see, these are straight lines, these are arcs, but there are only two partial spiral at the roof ridge that caused that pink surfaces to be ever so slightly doubly curved. And so strictly speaking, they are not developable, they can be unrolled onto the paper. But in most of the cases, because it was so slight, they could be made out of a flat sheet. But anyway, so to me, this was a complex enough geometry where I absolutely need a 3D model to control. But when it came to the point where we had a general contractor who wanted to get our design data, I was surprised to find that nobody, actually on the architect team and the contractor team, nobody used a 3D software. The only information that they asked me to provide were these points on those roof surfaces, how, the height of those points on the roof surface. The points are basically the intersection, you get the intersection of the grid lines in plan and project it back onto this roof surface, and how high is that point. So I just provided this sheet of paper, and they were, and I started teaching right after that, so I didn't get to actually participate in the construction phase. I left right before the construction started, but they were able to very truthfully build exact to the 3D model. And then I guess if I can keep talking, with the only one exception, which I was actually surprised. It was sort of I was pleased and disappointed at the same time. I guess I was disappointed that I wasn't there to resolve this portion with them, but I was very impressed that they have discovered this problem. So the problem was that because the result of that geometry, this very tiny portion of the roof turns out to be noticeable double curvature, where you have to do something, it can't be absorbed by the distortion of the sheet metal. So I knew that portion had to be segmented into some shape. But I never had that discussion with anybody on the contractor team. But when I visited the site after the building was completed, I found these sort of triangulated facet only where these double curvature existed. So one, I was super impressed that realized that without using any 3D software. Two, I think I wanted to also work out that problem with them.
Yeah, I think maybe kind of is a good thing to lead off, because this just because the fascinating has me thinking about it a bit. Like you're saying, like most of the time, right? Like you're not, you're not personally involved with the fabrication or construction of the thing, right? So it's always about this communication. But I think one of the things that you've continued to do throughout your career is producing these kind of experimental study models. Also kind of full-scale prototypes where you have like a much more direct relationship between the kind of production and design of it. I'm thinking of kind of like the tree pavilion that you did, or the kind of structural prototype that you did recently out of sheet metal. as a good example of that, you could maybe talk a little bit about why it's important to you to kind of continue to work back and forth through like more direct hands-on applications, but also, like how you begin to engage the constraints of production when producing like a pavilion, like the kind of branch pavilion that you did.
Yeah. So with a very little time left, that's a very, again, a loaded question to sort of unpack. But I think to me I think I'll go back to the very sort of first comment I made about the criticism that was being made at SCI-Arc about digitally oriented workflow from the physical oriented people, because you can make anything in the computer, but you have no idea how to build it. To me, it's not a dichotomy, right? And I think it's already obvious. It probably wasn't obvious in 2004, but at this time, it's probably pretty obvious to everybody that the digital tools and all of these construction fabrication issues, they supplement each other, right? Rapid prototyping is a way to prototype something physical so that you see it in your hand and you actually get to interact with that thing, and you find immense amount from this physical stuff, directly in your hand and studying with, fiddling with the object. So that's why, to me, the physical model making is still a very powerful tool. And I think on this competition, even like these sort of physical model making provided some insight into how this construction system that we didn't get to build might be able to work. So that's a feedback loop. And on this pavilion too, where I did for this in collaboration with Arctura, who does sheet metal fabricating, it was also very early on, we did this cardboard mock-up, knowing that it's not going to stand up, but just to show the one-to-one size and how do you put them together and show that to the fabricator, and they get some learning. And we were studying these, and like we learned that node had to be strengthened, and so they came up with various different ways of how to strengthen them. So we came up with this system so that was the only part that it had to be reinforced with members that's other than sheet metal that folds up like this. And yeah, I guess I should end there.
Are those nodes 3D printed?
Yeah, so the nodes are 3D printed. And then you sort of embed a threaded rod, and I don't know how you call it, but the negative of the threaded rod that the rod can thread into. So you embed that threaded cap into the 3D printed parts so that you can screw this rod onto, so you can put those together. Then you screw the sheet metal onto it.
Yeah, so I mean, we're kind of running out of time. So I guess, through these exercises, like where do you see kind of continuing this work, and like what are your kind of next ambitions for applying like stuff that you've learned from this production or maybe from the Talent Pavilion?
Yeah, I mean, I think it could be a lot of things, but as we've been discussing outside of this interview, it would be great to do some prototype of, an actual habitable space. So I think in LA, these accessory dwelling unit is becoming a very sort of interesting topic, and prefabricated housing, which is being topic for the longest time. But yeah, that's something that would be interesting.
Yeah, that seems like a next kind of logical step in some way, like going from communicating one-off projects to contractors or building code people to kind of figuring out how to develop a project and communicate these tectonic systems for things which have to be kind of mass produced or automated to some extent. it's kind of like another layer that you'll be adding to this research that you're doing. Great. Well, thanks, Yasushi. It's been a pleasure speaking with you.
Thank you.